Hello everyone, my name is I'm going to make a simple model in ABAQUS CAE. For a start, I select with a standard explicit model and create parts. For the first step, I give a name, suitable name to your part. If you don't give a name your part, ABAQUS names part same as part 2, part 1, part 2 to part n. I want to make a model on axis symmetric, and type of model is deformable, and base feature is shell. Continue, create rectangle 0, 0 to, for example, 20, 20 and 40. It is a rectangle. We can also disappear gauging our sketch area. Cancel procedure. Done. Next step, we define material behavior. So definition of just elasticity is enough. Mechanical elasticity, elastic Young model, for example 1E10 kilopascal, and point 3 is Poisson ratio. Assign section. For most of modeling, create a set is not necessary. Done. So section for axis symmetric 2D planar, for plane S3 modeling, and also for all 3D modeling space, we have to select solid homogeneous. Assembly. We have to do assembly procedure just even for one part, and we can also select create instance from parts or model. In this modeling procedure, we have to select parts and instance type. In most of our problems, we will select independent mesh on instance. It means if you have got a lot of parts in a model, when you select independent, you will mesh all of your model in the same space. Okay, independent step. In a step, we select our solver, and also type of analyze. For example, static analyze, or consolidation analyze, or transfer, static or dynamic explicit, or dynamic implicit. For this type of modeling, selection static general is enough, and also we can we should give a name for this step. Okay, in basic category, we should enter a time period even though for static analysis. And nonlinear geometry is related to nonlinear effects of large displacements. Automatic stabilization is refers to some model that loading may disturb the model. We can select, for example, a specified dissipated energy fraction or a specified damping factor. And in incrementation, for static general, selection automatic is selected by ABAQUS by default, and maximum number of increments, we always try to give a big number for maximum number of increments. And increment size, we can give 10% of time increment for increments for initial. Minimum increment is time period. Time period is 1 second per 100,000. Its default value, we can change it to, for example, 1e minus 12. The maximum increments might be equal to the time period. Other equation solver, I always select direct method, and matrix storage, unsymmetric for static general analysis or static analysis. We select unsymmetric for matrix storage, solution technique for Newton, and default load variation with time ramp linearly over step. Okay, interaction. If you have interaction problem, you should define it in this module. Interaction, for example, surface to surface, not to surface, or constraints and links, and explosion. We can define in all of them in interaction. Load is a very important part of modeling procedure. We can define loads and boundary condition and also initial condition for our model. For example, I want to define a circular load in this model. Before definition of circular load for my model, I have to use partition for make a suitable area for loading. Base a sketch. For example, my loading diameter is 1 meter. So, because of axisymmetric modeling procedure, I have to enter 0.5, and this is not suitable place for this line, so we have to select again and 0.5 and use flip for more this line for suitable place. Okay, done. Load, create load, pressure. I want to use a pressure load in this problem, pressure loading, and select this area. 10,000 Pascal is my load, is load in this problem. And boundary condition, side, for example, select symmetry, unsymmetry, and in case U1, UR2, UR3, all of this situation are 0, and side right displacement should try to define boundary condition is initial step. Displacement and rotation, select right side U1, just U1. You can also move left and move right your boundary condition. Side right, just U1. Button. Keep, shift, and select these two lines. Select these two lines and fix it in two directions, 1 and 2. Okay, let's go for meshing. Mesh. For the first step, I want to select seed edges, and I will select all model and give by number 4 is enough. Then I will select vertical lines and horizontal lines and give a suitable mesh size. A result around this area is important. For this purpose, we have to make fine mesh in this area. But the number of elements, for example 20, and a bias ratio is the ratio of maximum model to maximum length of maximum element to minimum element is bias ratio. Okay, select mesh part instance. Yes, this is mesh of this model. Then go to job, create a job, circular load. Okay, we don't have to define, don't have to change general memory parallelization, precision for simple problem. Submit. Okay, it is completed. Results. Primary result, for example, vertical displacement and also vertical stress distribution. I want to make a path, create, node list, add B4, select first point and second point. Done. Okay, go to KFXY data, add, and apply plot on default or intersect. Yeah, this is our result, but it is not correct because we have applied 10 kilopascal load above for this area. So I have to get a result same as this, but it has to start from 10 kilopascal, not about 8 kilopascal. What's the matter? It's exactly related to mesh. Let's go change mesh series. I want to give 40 for number of elements and 2 for 10 for bias ratio. Okay, let's go analyze again. You can monitor your modeling, your solving procedure, result, plots. S2, 2. Yes, this is exact result. It should be start from 10, and this is a good behavior and also correct result for this analysis. Thank you.